Welcome. In the next few minutes, you will see 10 Python concepts that every developer needs to know. We cover variables, functions, classes, list comprehensions, decorators, generators, error handling, type hints, modules, and async programming. Each concept builds on the last. Let's go. Python has 4 basic data types: integers, floats, strings, and booleans. You create a variable just by writing a name and assigning a value. No type declaration needed. Python figures out the type for you. You can check the type with the type function. Python also has none, which means no value. One important thing: variables are case sensitive. Name and name are 2 different variables. Collections like lists, tuples, sets, and dictionaries are also built in. A list uses square brackets and can hold any mix of types. A tuple is like a list, but cannot be changed after creation. A dictionary maps keys to values using curly braces. A function lets you reuse code. You define it with the def keyword, give it a name, and list parameters inside parentheses. The body is indented. Use return to send a value back. If you skip return, the function returns none. Python supports default parameter values. If a caller skips that argument, the default is used. You can also pass arguments by name instead of position. This makes code easier to read. Functions can accept any number of arguments using *args for positional ones and *quargs for keyword ones. Functions are first-class objects in Python. You can store them in variables, pass them to other functions, or return them from functions. A class is a blueprint for creating objects. You define it with the class keyword. The init method runs when you create a new object. It sets up the object's data. The first parameter of every method is self, which refers to the current object. You access attributes and methods on an object using a dot. A class can inherit from another class. The child class gets all the methods of the parent. You can override a method by redefining it in the child class. Use super to call the parent version. Python also supports properties, getters and setters that look like regular attributes, but run code when you read or write them. A list comprehension creates a list in one line. You write the expression, the loop variable, and an optional condition inside square brackets. It is faster and shorter than a regular for loop. You can filter items by adding an if clause at the end. Nested comprehensions work too, but keep them simple or readability suffers. Dictionary comprehensions use curly braces and a colon to build a dict in one line. Set comprehensions are similar but produce a set. Generator expressions look like list comprehensions but use parentheses. They do not build the whole list at once. Instead, they produce one value at a time, which saves memory for large data sets. A decorator is a function that wraps another function to add behavior without changing its code. You apply it with the @ symbol before the function definition. When Python sees the decorator, it passes the function below it as an argument to the decorator and replaces the original function with whatever the decorator returns. Use functools.wraps to preserve the original function's name and docstring. Decorators are used for logging, timing, access control, and caching. You can stack multiple decorators on one function. They apply from bottom to top. Decorators can also accept arguments. For that, you add one more layer, a function that takes the arguments and returns the actual decorator. A generator is a function that produces a sequence of values lazily. Instead of returning all values at once, it yields one at a time. When you call next on a generator, it runs until it hits a yield, returns that value, and pauses. The next call resumes from where it stopped. This is memory efficient for large sequences because only one value exists in memory at a time. You can loop over a generator with a for loop, just like a list. A generator also has a send method to pass a value back into the paused function. Generators are the foundation of Python pipelines, infinite sequences, and streaming data processing. Python uses try and except blocks to handle errors. Put the risky code inside try. List the exceptions you expect and except clauses. You can catch specific exception types or use a bare except for everything. The else block runs only if no exception occurred. The finally block always runs, even if an exception happened. Use it to release resources like files or connections. You can raise your own exceptions with raise. Create custom exception classes by inheriting from exception. Add a meaningful message and any extra data the caller needs. Good error handling makes your program predictable and debuggable. Avoid swallowing exceptions silently. Always log or re-raise them. Type hints let you annotate variables and function parameters with their expected types. Python does not enforce them at runtime, but tools like mypy and Pyrite use them to catch bugs before you run the code. Import optional from typing when a value can be none. Use union to allow multiple types. List and dict from typing describe collections with specific element types. In Python 3.10 and later you can use the pipe operator instead of union. Type dict lets you describe dictionaries with specific key names and types. Protocols define structural types. Any class that has the right methods matches the protocol without explicit inheritance. Type hints also serve as documentation and make refactoring much safer. A module is just a Python file. You import it with the import statement. Use from module import name to bring one item into the current namespace. A package is a directory with an init.py file. That file runs when the package is imported. You can use relative imports inside a package with a leading dot. The standard library has modules for math, file handling, HTTP, JSON, dates, and much more. Third-party packages are installed with pip. Organize large projects into packages with clear boundaries. Avoid circular imports. They cause errors that are hard to debug. Use the all variable to define which names a module exports publicly. This keeps the public interface clean and intentional. Async programming lets your code do other work while waiting for slow operations like network requests or file reads. You define an async function with async def. Inside it, use await before any operation that could be slow. The await suspends the current function and lets other tasks run. The Asyncio module runs async code. Use asyncio.run to start the event loop from regular code. Use asyncio.gather to run multiple coroutines in parallel. Async is not threads. It is cooperative. One task runs at a time, but it voluntarily pauses when waiting. This makes it efficient for input and output-heavy programs. For CPU-heavy work, use threads or multiprocessing instead. You just saw 10 Python concepts, variables and types, functions, classes, list comprehensions, decorators, generators, error handling, type hints, modules, and async programming. These are the building blocks of every serious Python project. The best way to learn them is to use them. Pick one, write a small program, and move to the next. If this was useful, subscribe for more Python content. See you in the next one.